Until now, AI has primarily existed inside computers, processing information in the digital world. It generates text, recognizes images, and analyzes vast amounts of data. But today, a major transformation is underway. AI is no longer confined to digital space. It is stepping into the physical world. In factories, intelligent robots are performing complex manufacturing tasks. In the sky, autonomous drones are delivering goods and inspecting infrastructure. On our roads, self-driving vehicles are beginning to reshape transportation. AI is no longer just producing answers on a screen. It is moving, making decisions, and interacting with the real world. This is the beginning of a new era, physical AI, and this transformation represents far more than another advancement in artificial intelligence. It has the potential to fundamentally reshape our industries, our infrastructure, and the way society itself operates. Welcome to the age of physical AI. Until now, most of the AI we have used has operated in the world of information. It searches for knowledge, generates content, analyzes data, and communicates with people. In other words, AI has primarily been designed to think, understand, and reason. But the next generation of AI goes far beyond that. AI is no longer limited to processing information. It is beginning to act in the physical world. It can move through real environments. It can grasp and manipulate objects. It can carry materials from one place to another. And it can execute tasks while coordinating with people and other AI systems. This is the essence of physical AI. AI is evolving from a technology that understands information into a technology that transforms the real world through action. This is more than just another technological advancement. It marks a fundamental shift in the role of artificial intelligence. From thinking AI to acting AI, AI is beginning to gain a physical presence. Until now, AI has been the intelligence of information. It learned from data, understood knowledge, and performed reasoning within the digital world. Its primary role was to process information and assist human decision-making. But with physical AI, that intelligence is expanding beyond the screen and into the real world. AI can now perceive its surroundings through cameras. It can sense the environment using a wide range of sensors. It can grasp objects with robotic arms. It can move using legs, wheels, or autonomous vehicles. And most importantly, it can carry out real-world tasks. In other words, AI is evolving from having only a brain to having both a brain and a body. The intelligence of the future is no longer just about understanding information. It is about perceiving the physical world, making decisions, taking action, and continuously learning from the results. This marks a fundamental transition from information intelligence to physical intelligence. AI has entered a new stage of evolution, where intelligence is no longer confined to digital information, but becomes an active force in the physical world. Giving AI a physical body is an important milestone, but a body alone is not enough. Having the ability to move does not automatically mean having intelligence. What truly matters is how that body is used. Even the most advanced robot cannot operate safely in society unless it understands the situation and chooses the right action. That is why the future of physical AI is not defined by its body, but by its intelligence. First, it needs judgment, the ability to understand a situation and make the best possible decision. Second, it needs coordination, the ability to work together with people, other AI systems, and robots to achieve shared goals. Third, it needs responsibility, the ability to take ownership of its actions and explain why those actions were taken. And finally, it needs boundaries, a clear understanding of the safety, ethical, and legal limits that must never be crossed. The true goal of physical AI is not simply to build more capable robots. It is to design intelligence that can act safely, responsibly, and earn the trust of society. The body is only the vessel. What truly matters is the intelligence that gives that body purpose and meaning. Over the past few years, generative AI has advanced at an extraordinary pace. It writes documents, creates images, generates software, and helps us discover new knowledge and ideas. In other words, generative AI produces information, but physical AI is aiming for something beyond information. Its goal is not simply to generate content, but to act in the real world and create tangible value. Imagine a robot transporting packages through a warehouse, a robotic arm assembling products on a factory floor, a drone inspecting critical infrastructure, or an autonomous vehicle safely delivering people and goods to their destinations. In each of these examples, AI's decisions are translated directly into real-world actions. That is the fundamental difference. Generative AI creates information. Physical AI transforms reality. The evolution of AI is moving beyond thinking alone. It is becoming capable of acting. And through those actions, AI will create new value for people, industries, and society itself. This is the next chapter in the evolution of artificial intelligence. With physical AI, a single decision can immediately become a real-world action, and those actions can directly affect people, property, and the environment. Imagine that a sensor and an AI system determine there is no obstacle ahead. Based on that signal, a robot moves its arm. An autonomous vehicle begins to drive. But what happens if that decision is wrong? A robot could collide with a person. A package could be dropped. Equipment could be damaged. Or in the worst case, a single mistake could lead to a serious accident. This is the critical difference between digital AI and physical AI. What AI produces is fundamentally a signal. A signal provides valuable information, but it is not the final decision, and it is never guaranteed to be correct. That is why a signal should never be translated directly into action. Before execution, the situation must be verified. Safety must be evaluated. When necessary, a human should be able to intervene, and the system must determine whether the action is truly safe to perform. In physical AI, decision-making and execution are inseparable from the real world. Every action carries responsibility. That is why designing clear boundaries, the rules that ensure safety, accountability, and human oversight, is essential for every intelligent system that acts in the physical world. There is one critical idea to understand. What AI produces is not yet a decision. The output of AI is a signal, information or a recommendation that supports decision-making. For example, an AI might report, "No obstacle detected. This is the optimal route. A potential anomaly has been identified." These outputs are valuable, but they are only inputs to the decision-making process. A real decision requires much more. Is it truly safe to proceed? Does the action comply with regulations and organizational policies? Who is responsible if something goes wrong? And should the action be approved for execution at all? Only after considering these questions can a final decision be made. That is why a signal is not the same as a decision. In physical AI, this distinction is fundamental. Safe and trustworthy AI systems are not built by executing AI outputs automatically. They are built by transforming signals into well-governed decisions through human oversight, safety checks, and clear operational boundaries. That transformation, from signal to decision, is the foundation of responsible physical AI. If AI outputs are only signals, then an important question remains. How do we turn those signals into safe and responsible decisions? The answer is what we call the decision runtime. It begins with an event, something that happens in the real world. Sensors and AI systems observe that event, analyze it, and produce a signal. But that signal should never be executed automatically. Between the signal and the final action, there must be a runtime. The runtime is where AI outputs are evaluated within their full context. It considers operational rules, safety requirements, legal regulations, organizational policies, and human intent. It asks critical questions. Is this action safe? Are there better alternatives? Does this require human approval? Only after these questions have been answered can a responsible decision be made. In other words, the decision runtime transforms AI outputs into meaningful, accountable decisions. The future of physical AI depends on more than powerful AI models. To operate safely in society, AI needs an intelligent decision-making layer that evaluates every signal before it becomes action. That layer is the decision runtime, the foundation that makes physical AI trustworthy, responsible, and safe. Everything we have discussed so far comes together in a single framework, the decision trace model. The decision trace model is an end-to-end execution model that transforms AI outputs into meaningful decisions, responsible actions, and accountable records. It begins with an event, something that happens in the real world. AI systems observe that event through sensors and analysis, producing a signal. That signal then enters the runtime, where it is evaluated within its operational context. Here, the system considers applicable rules, environmental conditions, organizational policies, and technical constraints before determining whether an action should proceed. Next comes the boundary. At this stage, every potential action is checked against safety requirements, ethical principles, legal regulations, and organizational governance. If human oversight is required, the process moves through the human gate, where a person can review the situation, provide approval, or make the final judgment. Only then does the system proceed to execution, allowing robots or other autonomous systems to act in the physical world. Finally, every step of the process is recorded in the ledger, not only what happened, but why the decision was made, how it was evaluated, who approved it, and which rules and boundaries guided the action. This creates a complete and verifiable record of accountability. The goal of the decision trace model is not simply to control AI, it is to connect AI reasoning, human responsibility, and societal trust into one continuous decision-making process. In the age of physical AI, powerful AI models alone will not be enough. The systems that will shape the future are those that can connect decision, execution, accountability, and trust into a single, transparent architecture. That is the vision of the decision trace model. Among all the components of the decision trace model, the most important is the boundary. But what exactly is a boundary? A boundary is the guardrail between decision and execution. Even after an AI system, or a human, has made a decision, that decision should not be executed immediately. Before any action is taken, one final question must be answered. Should this decision really be carried out? The boundary exists to answer that question. It verifies whether the decision is safe, whether it aligns with ethical principles, whether it complies with laws, regulations, and organizational policies, and whether responsibility for the outcome is clearly defined. Consider a few examples. For an autonomous vehicle, the boundary checks whether executing the decision could endanger human life. For an industrial robot, it verifies that no worker has entered a hazardous area. For a medical AI system, it ensures compliance with clinical guidelines and healthcare regulations. For a financial AI system, it helps prevent fraud, discrimination, and regulatory violations. The boundary is far more than a safety mechanism. It is the place where society's values are translated into operational rules for AI. It brings together safety, ethics, compliance, and accountability before any action is allowed. That is why, in the decision trace model, every decision must pass through the boundary before execution. Powerful AI models alone cannot earn society's trust. Trust comes from ensuring that every action has been verified, every risk has been considered, and every responsibility is clear. Because the boundary exists, AI decisions can be carried out safely and responsibly in the real world. That is why the boundary is the central pillar of the decision trace model. Now let's take a closer look at the role of the boundary. Every AI system has two different capabilities. There is what AI can do, and there is what AI should do. These are not the same. For example, AI can technically recognize faces. It can analyze enormous amounts of data. It can control robots and drive autonomous vehicles. These are questions of technical capability. But society asks a different question. Should the AI actually perform that action? Is it safe? Is it ethically acceptable? Does it comply with laws, regulations, and organizational policies? And who will be responsible for the outcome? These are not questions that AI performance alone can answer. That is exactly why the boundary exists. The boundary does not simply ask whether AI can execute an action. It determines whether AI should execute that action. It connects technical capability with human values, ethics, governance, and accountability. In other words, the boundary is not designed to limit AI. It is designed to enable AI to operate safely, responsibly, and in a way that society can trust. As physical AI becomes more powerful, success will no longer be measured only by what AI is capable of doing. The real challenge will be deciding how AI should be governed and how it can coexist with society. That is why the boundary is at the heart of the decision trace model. It bridges the gap between what AI can do and what AI should do. There is one more essential component in the decision trace model. It is called the human gate. The human gate is where human responsibility enters the AI decision-making process. AI can analyze enormous amounts of data, identify patterns, and recommend what it believes is the best course of action. But deciding whether that recommendation should actually be carried out is ultimately a human responsibility. The human gate begins with safety verification. Will this action put people, equipment, or the environment at risk? Next comes ethical judgment. Does the proposed action align with human values and organizational principles? Then comes rule compliance. Does it satisfy legal requirements, industry regulations, and internal company policies? Based on all of these considerations, a person makes the final decision. Should the action be approved? Should it be postponed? Or should it be rejected entirely? This is why the human gate is much more than an approval button. It is also the place where we can say stop if something is unsafe, unethical, or inappropriate. The human gate prevents execution before any real-world action occurs. It is also where decisions become explainable. People must be able to explain why a decision was made, and they must be able to identify who is accountable for that decision. AI provides recommendations. Humans provide responsibility. In the end, AI is a decision support system, not the accountable party. The final decision, and the responsibility for its consequences, always belong to people and the organizations they represent. That is why the human gate is the final bridge between artificial intelligence and human accountability, making trustworthy physical AI possible. Now, let's reconsider the way we think about AI systems. For many years, the dominant idea has been human in the loop. The AI makes a recommendation, and a human reviews it afterward. In this model, people are treated as observers standing outside the AI system. But in the age of physical AI, that way of thinking is no longer enough. Humans are not outside the system. They are part of the very structure of decision-making. Every meaningful decision begins with human intent. What are we trying to achieve? What values should guide our actions? What context should the AI understand? These human goals and values become the starting point for designing the decision flow. Within that structure, AI analyzes information. Organizational rules are applied. Human judgment is incorporated, and only then does execution take place in the real world. In other words, people do much more than approve decisions at the end. They shape the decision-making process from the very beginning. The most important question is no longer simply who made the decision. The real question is, what decision structure produced that decision? What values guided it? How was it designed? And can every step be explained and traced? In the next generation of AI systems, humans and AI are not competing with one another. They work together as parts of a single decision-making architecture. Human values provide the purpose. AI provides analysis. The decision structure connects them, and execution turns those decisions into real-world actions. That is the vision of the decision trace model, a system where people are not outside AI, but at the very center of how intelligent decisions are made. At this point, we need to rethink what intelligence really is. For a long time, we have assumed that intelligence exists inside a single AI model or a single robot. But is that really true? A robot alone cannot function. Without sensors, it cannot perceive the world around it. Without rules, it cannot determine what actions are appropriate. Without humans, it has no purpose, no values, and no understanding of what truly matters. And without infrastructure and organizations to support it, it cannot operate reliably in society. In other words, intelligence does not exist as a single entity. It emerges from the interaction of many different elements: robots, humans, sensors, rules, infrastructure, organizations. Each contributes a different capability. Only when these elements are connected, sharing information, coordinating decisions, and working toward a common purpose, does intelligence truly emerge. If even one of these pieces is missing, the entire system becomes incomplete. That is why the future of AI is not simply about building more powerful models. It is about designing the relationships between all of these components. The true foundation of intelligence is not the collection of individual elements. It is the structure of their relationships. This idea, that intelligence emerges through relationships rather than existing in isolation, is the starting point of our research. It is the principle that connects the decision trace model, multi-agent systems, and ultimately the vision of a runtime society. In the age of physical AI, intelligence is no longer something that belongs to a machine. It is something that emerges from an entire ecosystem working together. As we have seen throughout this presentation, intelligence does not exist in isolation. So what is the true nature of intelligence? We believe the answer lies in relationships. Consider all the elements involved in an intelligent system: robots, humans, sensors, data, rules, infrastructure, organizations. Simply bringing these components together does not create intelligence. What truly matters is how they are connected, how they share information, how they understand a common purpose, and how they coordinate their actions. When these relationships are carefully designed, something remarkable happens. The individual elements begin to work together. They align their goals. They adapt to changing situations. They collaborate to solve problems. This is coordination. And when relationships and coordination function together, intelligence emerges. The result is far more than technical capability. It becomes the ability to adapt to change. to make sound judgments in complex situations, to create new value, and ultimately, to build trust and enable meaningful co-creation between humans and AI. In other words, intelligence is not the performance of a single AI model, nor is it the ability of a single human. Intelligence is an emergent property of relationships. That is why the future of AI is not simply about building larger models or more powerful algorithms. The real challenge is designing the relationships between people, AI systems, organizations, and society. The future of intelligence will not be defined by the power of individual machines. It will be defined by the quality of the relationships they create. That is the central idea behind our research, and the foundation of the decision trace model, multi-agent coordination, and the vision of a runtime society. So far, we have explored how a single AI system can make safe and responsible decisions. But the future will not be built around isolated AI systems. It will be built around many AI agents working together. Imagine a world where robots, drones, autonomous vehicles, factories, and entire cities operate simultaneously. Each has its own role. Each gathers different information. Each contributes unique capabilities. A drone surveys the environment from above. An autonomous vehicle delivers people and supplies along the safest route. Robots manufacture products on the factory floor, and smart city infrastructure continuously optimizes transportation, energy, and public services. None of these systems works alone. They share information. They understand one another's roles. They coordinate their actions, and together, they pursue a common objective. This is the world of multi-agent systems. The key challenge is no longer the intelligence of a single AI. It is the intelligence that emerges from coordination among many AI agents. Information sharing, role assignment, collaborative planning, consensus building, and continuous self-optimization. Together, these capabilities create a level of intelligence that no single agent could achieve on its own. The future of physical AI is not a society where individual AI systems compete. It is a society where diverse AI agents collaborate with one another, and with people, to create value together. And to make that collaboration safe, transparent, and trustworthy, we need a shared decision-making foundation. That is why frameworks such as the decision trace model and the decision runtime become even more important. They provide the common language and governance that enable many intelligent agents to work together as one coordinated system. This is the vision of the physical AI society. In a physical AI society, intelligent decisions are rarely made by a single AI system. Instead, multiple AI agents work together. They share information, they divide responsibilities, and they coordinate their actions toward a common goal. But this raises an important question. How do we know whether that coordination was actually effective? The answer is coordination trace. Every agent begins by observing its environment, gathering information, and sharing what it knows with other agents. Based on that shared information, each agent evaluates the situation and makes decisions appropriate to its role. The agents then communicate their intentions, negotiate responsibilities, align their plans, and coordinate their actions. Finally, those coordinated decisions are executed in the real world. But the most important part comes afterward. Every step of this collaborative process is recorded. Who shared which information? Why was a particular decision made? How were roles assigned? How did the agents coordinate with one another? What actions were taken? What outcomes were achieved? And what was learned from the experience? By recording this entire process, we gain something far more valuable than an execution log. We gain a complete picture of how intelligence emerged through collaboration. This makes the entire coordination process transparent. It allows decisions to be verified. It makes complex behavior explainable. And it enables continuous improvement through learning from past experience. If the decision trace model records how a single AI system, or a human, arrives at a responsible decision, then coordination trace records how multiple AI agents and humans work together to create value. In the age of physical AI, intelligence will no longer be measured only by the capability of individual agents. It will also be measured by the quality of their coordination. The ability to record, understand, improve, and evolve that coordination will become one of the fundamental foundations of next-generation intelligent systems. That is the purpose of coordination trace. Everything we have explored so far leads to one central idea. The decision trace model is more than a framework for AI. Its ultimate purpose is to provide the governance infrastructure for a trustworthy society. It begins by recording every decision. Every choice is structured, Every process becomes traceable. Every action can be verified. As a result, we can answer the questions that truly matter. Who made the decision? When was it made? What information was used? Why was that decision chosen? These records become the foundation for governance. Governance is not about controlling AI. It is about creating the conditions under which AI can operate responsibly within society. It establishes clear rules, defines responsibilities, verifies safety through boundaries, and continuously audits, evaluates, and improves the entire decision-making process. When this governance framework extends beyond individual systems, it begins to transform society itself. Transparent decisions build trust. Clear accountability gives people confidence. Traceable records reduce risk by making problems easier to detect, investigate, and correct. And continuous feedback allows AI systems, organizations, and society to keep learning and improving together. This is why the decision trace model is much more than a technical architecture. It is the foundation for recording, governing, collaborating, and co-creating in the age of physical AI. Our goal is not simply to build more capable AI. Our goal is to build a society where people and AI can work together with transparency, accountability, and mutual trust. That is the vision of the governance infrastructure, a foundation that enables intelligent systems to create lasting value while earning the trust of the society they serve. Before we move to the final vision, let me leave you with one important message. The future of AI does not depend on building the most powerful model. For years, the AI industry has focused on making models larger, faster, and more accurate. More parameters, higher benchmark scores, better performance. These achievements are important, but performance alone is not enough to create AI that society can truly trust. Even the most advanced AI can make the wrong decision, and when AI acts in the physical world, a single mistake can have real consequences. That is why the real challenge is no longer how powerful AI becomes. It is how we operate AI responsibly. To achieve that, we need a complete decision-making foundation, a runtime that provides a safe operating environment, a boundary that defines what AI must never cross, governance that establishes rules, responsibilities, and oversight, traceability that records every decision and makes it explainable, and finally, human judgment, because people remain responsible for the decisions that shape society. Only when these elements work together can AI become a trusted partner in the real world. Our goal is not to build the world's most powerful AI. Our goal is to build AI that people can trust, collaborate with, and rely on every day. AI that creates value. AI that operates responsibly. AI that strengthens society. The future of AI will not be defined by model performance alone. It will be built on runtime, boundary, governance, traceability, and human responsibility. But there is one final question. What kind of society becomes possible when all of these foundations come together? Let's look at that vision next. Throughout this presentation, we have explored the future of physical AI. We began with a simple question. What happens when AI leaves the digital world and begins acting in the physical world? As AI moves beyond generating information and starts making decisions that affect people, organizations, and society, intelligence alone is no longer enough. AI must operate responsibly. It must work within clear boundaries. Its decisions must be explainable. Its actions must be accountable. And above all, it must collaborate with people. That is why we introduced the decision trace model, a framework that transforms AI outputs into responsible decisions. From there, we expanded the idea to coordination trace, where multiple AI agents can work together transparently and safely. And finally, we arrived at the vision of a runtime society, a society where humans and AI continuously collaborate, learn from one another, and create value together. This changes the way we think about intelligence itself. Intelligence is no longer the capability of a single model. It is the result of relationships, of coordination, of trust, and of shared responsibility. That is why the goal of the next generation of AI is not simply to build larger models or achieve higher benchmark scores. Our goal is to build AI that society can truly trust. AI that works with people. AI that creates value responsibly. AI that helps build a better future. Because in the end, the future of AI is not intelligence. It is coordination. Thank you very much for watching. If this vision resonates with you, I invite you to explore more of our research at Chinoba.org, where we continue to develop the concepts of decision trace model, coordination trace, and runtime society. Thank you.